work. It's because they've broken up what needs to be put into the same script container for correct UDP and TCP messaging. So we're going to put this to the side for right now, and we'll get into the details here in just a moment. So we restarted the server, and now we're listening. It's running on these ports. I'm going to go over to the client, and I'm going to start the client. Now, this should work because we're on the same computer. The message, this is line 2, and I'm going to put in the word "and more." Let's see if it works. Okay. What happened was we sent out on port number 4567, and that's where I just said something that most people get stumbled on, and I said that on purpose. We didn't send anything out on port 4567. We sent something out, say to the operating system, send this to this IP address, and have it come in on port 4567. The operating system chose some port at random to send the information out, and we don't really care what port that is. The effective route is that from our client, we went out, back in, and onto the Echo server line. We see this is line 2 and more. And because of the programming I'll show you in just a moment, this event log says we're sending this line, and the packet arrived, and here's what we got back from the server. So the server has been programmed to send back 3 pieces. 1, 2, 3. It doesn't echo the message, it just echoes some of the information that it collected after having received the packet. This is how you can confirm that messages got to the destination when you're doing your work, and you may choose not to keep this little echo packet arrived kind of thing. It's just your choice. So when you're developing and testing, and I'll show you some of the little tricks here in a moment, developing and testing means that you need to verify packets actually leave, they actually come back in, they don't lose data, and as you get going in a more sophisticated way, the timing stays true. Now, when I was doing work between Seattle and London, the round-trip time for packets was basically 210 milliseconds. If it got above 350, I knew I had a very slow connection. If I was doing it between Las Vegas and Los Angeles, or Seattle and Los Angeles, I would expect something in the order of 110 to 120 milliseconds for a good running connection. If I do it across town, say in Vegas or LA, doesn't really matter where, but across town, you really should get something on the order of 35 to 50 milliseconds, sometimes 15 or 20. But that means a nice, snappy connection. And this is important when you're using UDP, because that's one of the reasons you're saying, well, is my system going fast or slow? I'm going to show you one part of the script to highlight why your system could test okay and then not test so well 1 hour later, 2 hours later, and you get confused. Now this is going in just a little bit deep, but this is the idea that we're following sockets. And we know, because I described, that UDP client didn't use port 4567 to send this message. It said to the operating system, use whatever port you want. So the operating system may have opened up port number 37,462 saying, here it goes, because it doesn't really matter. When it does matter is when you come into a situation and you've been sending a lot of messages, the operating system keeps opening up these ports, and what people don't realize is that a function in Livecode called the open sockets tells you what sockets are open for either the standalone app or our IDE at this point. So here comes the key point. If the operating system says to this client, I will send your message, and I will open a little port temporarily and send it, and everything is fine. What may not happen is that the operating system closes that port. Next time you send a